projectile motion. I'm just going to do a very quick recap. Please follow, be with me as we move now together into this thing. I said the very first slide will indicate two critical definitions. One is what is a projectile, two is what is a free fall. Now a projectile is an object that has been given an initial velocity and on which the only force acting on it is the force of gravity or the gravitational force. Ladies and gentlemen, what does this say? It says now, because the topic itself says it is a vertical projectile motion, it means now the object must either be moving up or down. Vertical we mean. But a projectile, keyword, it is an object. But this object has been given an initial velocity. It's either we drop or we throw. Remember, if we drop, it will go down. If we throw, then we decide to say, am I going to actually throw it up or down? That is now an important question that one must ask themselves. I'm going to throw it, yes. But am I throwing it up or am I throwing it down? What will happen in that regard? Now, because this object is moving up and the only force acting on it is the force of gravity, we agreed to say if I was expected to draw a free body diagram, what must I do? Very, very easy. The only force is the force of gravity. Nothing more, nothing less. So it means I only have one force. And what force is that? Force of gravity. What is the direction of force of gravity? Downward. So the gravitational acceleration will always now be downward. And it is a constant of 9.8 meters per second. It says here, whether the object is moving up or down, the only force acting on it, it is a gravitational force. Ladies and gentlemen, we agreed it is given an initial velocity. When it is given an initial velocity, it is either dropped or thrown. So when you throw it up, still when it is going up, the only force is force of gravity. When it's coming down, the only force is force of gravity. However, we have now a nice weight that we call a free fall. And this nice weight that we call a free fall, it is a motion of an object under the influence of the gravitational force only. What is this object, ladies and gentlemen? This object is actually a projectile. So when a projectile is in motion, we say it is in a free fall. What is a free fall? It is the motion of a projectile. But what is a projectile? It is an object that has been given an initial velocity and the only force acting on it is the force of gravity. 1 and 2, that means projectile and free fall, are two new definitions that we must know from grade 12. However, from grade 10, ladies and gentlemen, we must know acceleration, velocity, and displacement. Why? Because acceleration, it's there, 9.8 downwards. What is acceleration? The rate of change in velocity. What is velocity? The rate of change in displacement. What is displacement? The total distance covered what there. Then you give nice definitions from grade 10. Remember, ladies and gentlemen, the examiners are going to assess you based on what? Everything from grade 10 to grade 12. However, we know things that are key critical of importance for you to know from grade 10. Ladies and gentlemen, this topic, when I have explained what is a projectile, what is a free fall, and also drawing the free body diagram, one can basically say we are done with the topic. However, we are going to be exposed to what we call equations of motion. Now, equations of motion, Vf squared is equals to Vi squared plus 2g delta y. Equation 1. Vf is equals to Vi plus Gt. Equation number 2. Delta y is equals to Vit plus half Gt squared. Fine. But now there's this equation number 4. So quickly, VC, what is common in all these 3 equations that I have given you? One thing that is now common and it stands out.
So is it the velocity?
Velocity is everywhere, Vi. Okay, something else that stands out that is now in all the formulas. Again, another Moteo.
The 3 have acceleration,
All
while the fourth
three,
one doesn't.
all the 3, thank you very much, Moteo. All the 3 have GVC. GT, G delta Y, GT squared. But when you check the 4th one, it does not have the G, ladies and gentlemen. So now, my thinking is, because the 4th one does not have a G, it means it has not accommodated that much to the rule of working with a projectile and a free fall. Why, ladies and gentlemen? An object that has been given initial velocity and the only force acting on it is the force of gravity. So it must have the gravitational acceleration. For it to qualify as a projectile, it must have G. For it to qualify as a projectile, it must be in a free fall. And what is a free fall? Motion of an object under the influence of gravitational acceleration. Now, the 4th one, I am not saying it will not work. Yes, Moteo?
Oh no, sorry, sir, I did that by mistake.
Okay, no problem. Now, all 3 is the equations that I call my go-to equations. The 4th one will be it will be given. It is sometimes working, sometimes it does not work. Because for me, I consider it as more of an equation of motion for linear motion, like your horizontal motion. But however, I'm just saying be careful when you want to use equation number 4. But in most cases, 1, 2, 3 are my go-to formulas. Why? They all have G. G is now what? One of the key principles that allows us to talk of a projectile, to talk of a free fall. So the 4th one is there. Just be on the lookout. However, for me, it will be my last resort. And I want to encourage you also to say, let it be your last resort. Try to work with 1, 2, and 3. So what have we done? We have eliminated one equation. Somehow we are going to need it, but not that much. Ladies and gentlemen, the key critical thing, like I said, 1, 2, 3, topic done. Challenge how to apply now in terms of the sketches that are given or the problems that are given. So this is the hints that I gave to say on how to answer questions. On how to answer questions. Ladies and gentlemen, you may have your own way of doing things. This is my way, and I'm kindly sharing this way. Why am I sharing this way? It is experience that taught me to say, if I have a diagram of the problem, even if the examiner explains it in words, I must picture and try to draw a sketch diagram of now what the problem given. So when I have a sketch, when I am told that it is dropped from a certain height dropped from a certain height, then I must have my A there, I must have my B, just to know where I am in the motion of the projectile. This assists me to actually understand where is G is positive, where is G negative, and what is actually happening when I actually have the information that is given. Ladies and gentlemen, that path of the projectile, we call it a trajectory. So it says, draw a sketch diagram of the problems given. Label all the important parts of the motion. Hence, I'm having A, B. I will be able to say at A, then I have 0 meters per second. Why? Because maybe I am told that the object was dropped. Then I can say, do I have VF? I do not know VF, which is what? The velocity at which the object hits the ground. I exactly know where I am in the motion of the projectile. Ladies and gentlemen, we are working with vectors. And when we work with vectors, the choice of direction, Bonolo Matosa, is very, very important. Very, very, very important. Choice of direction. So I must tell the examiner to say I am taking downward as positive, I am taking upward as positive. It makes our life very easy. Everything that is a vector, when it is going down, it must be positive. Write down the variables given, the data. I highlighted in the previous sessions. Mr. Ditabe will attest to this, to say for us to perform problem or to answer a question, we only need 3 variables. Only 3. Why 3 in that number? Because, ladies and gentlemen, when you look at this equation, let me go back. I only need 3. Let's check with the first equation. I'm going to try and use yellow here. When I am given delta y, it will be 1. G is a constant, 1. Then the question can either ask of V initial or V final. Let's say they are asking V initial. Then I must just need that. It is 1, 2, 3. Easy. If I come to equation number 2, let's say now they want time, then it means I need V final, V initial, G is given, 1, 2, 3. Then I can calculate time. Let's look at equation number 3, ladies and gentlemen. If the question maybe wants delta y, let's check. T given, G given, Vi given. 1, 2, 3. Delta y, then I can perform a calculation. Hence the hint to say you only need 3. And in that 3, 2 variables will always be given. But for us to get this one, just this one, because 2 is given, you know G is already 9.8. It's there, it's given. And something will come from the examiner also. But obviously there's one thing that is hidden there. And how do we get that? That one thing that is hidden is the one that will ask us to apply the physics principle, to basically draw the sketch and understand where are we in the sketch or in the motion of the projectile. It can't be as easy as this. But the questions will be complex, obviously, because it's an exam, it's a test. But the easiest way of performing the calculations is to follow this principle. Now, I am not going to bore you with the one that is dropped because I want us to move. Everything is there. We'll incorporate that. So the examples are there. We did this nice example also. Mr. Ditabe and Realebua did not manage to get it right, and Lwanle, why? Because they failed to draw the sketch. Hence I have the sketch there. Hence I am telling the examiner where I am in my sketch. I'm at ABC or I am at B. Then they realized to say it is important, ladies and gentlemen, to draw the sketch. Now for today I want us to get into what I call type 2 problem. And what is a type 2 problem? Type 2 problem is an object thrown up from a starting point, and caught at the same point. That is where I want us to go. We will incorporate everything as we move. Ladies and gentlemen, this science is very simple. What do they say? Thrown up. So what am I going to do? I'm going to have it starting there, going up. Yes, VC. Thank you. Then it is going up, and then it says again from the starting point and caught at the same point. So it means it came down. Now let's use blue for the second part to say there. Now it's coming back to the starting position. Ladies and gentlemen, it is a sketch. It is the statement of the examiner. I don't have any information already because of the sketch. What can I do? I can say I have A, B, C. Very, very important points in my sketch. Automatically, what can I say? I can say obviously I need some V initial for it to go up. It will not go up without any velocity. So what can I say? I can say at A, V initial is greater than 0 meters per second. It's true. But decreases as the object approaches B. Motheo Siditi, is it possible for this object to change direction without stopping? Just yes or no. Is it possible for this object to change the direction without stopping?
Yes, sir.
Okay. Let's say then, at B, there's a lot of things happening. V is equals to 0 meters per second. G is equals to 9,8 meters per second squared. And obviously G here is also 9.8 meters per second squared. Now Mudia, let's check. What could be the reason that at A, V is greater than 0, but at B is equals to 0? What could be the possible reason for that?
Sir, I think that it stops when it reaches its maximum height, then changes direction.
Thank you very much. It has lost its momentum. So the momentum of this projectile is no longer there. So it must stop. So let's agree to say now this is at maximum height. Now at maximum height, ladies and gentlemen, because the object must change direction, it must stop. So all these things are things that we need to put into mind to say some information will be given, but I need to understand the science. Because if I say it is changing the direction and do not understand that now, it actually means for me to change direction, I must stop. And if I stop, then what must happen? Very easy, ladies and gentlemen, I'm going to be able to change the direction. Then I can easily say velocity increases as it falls back. True. And these questions, ladies and gentlemen, will be part of the multiple choice, or just part of your structured questions. Increase, decrease, or remain the same. You need to check where are you in the motion of the projectile. Now let's go to C. At C, can I write V initial is equals to V final? And I'm going to use this orange again and say this is V initial, and here we have V final. And I'm going to say from A to B, which is T1, from there to there, allow me to call it T1, and from there to there is T2. Can I say T1 is equals to T2? VC, can I say that? T1 is equals to T2 at C. The time taken for it to go up and to come back to my hand again is basically the same time.
Yes, sir, it is.
It is 100%. Why is it so? Ladies and gentlemen, we call it symmetry. We call it symmetry. The assumption is it should take, because remember the system is now told to say let's ignore the effects of friction. Then it means the only force there will be force of gravity, which is the same as it goes up and the same when it comes down. So remember, this skill of analyzing the questions or the information is very, very, very critical, ladies and gentlemen. Can I write to say delta y is equals to 0? Mr. Ditabe? Can I write that delta y is equals to 0?
Yes, sir.
Why could that be the reason?
Because it's going back to the same position to where it started.
Thank you very much, because it is a displacement. The fact that it is a displacement, ladies and gentlemen, because it is a displacement, remember, it means we are going to have delta y, which is just y of AB plus y of BC, but however choice of direction, we say everything going up must be positive. Y of AB positive minus y of BC. However, y of AB is equals to y of BC, ladies and gentlemen, and this will cancel and just give us that 0. Where does this thing of displacement come from? From grade 10, understanding the difference between displacement and distance, ladies and gentlemen. And this is type 2. Obvious, in an exam we are going to combine type 1, type 2, and maybe type 3. So the easiest thing to do now is to perform a calculation. Maybe without wasting any time, I should just check. Mr. Ditabe, questions please.
I'm good, sir.
Thank you very much. Motheo CDT.
I'm good, sir.
Thank you very much. VC.
I'm all good, sir.
Thank you very much. Bonolo Matosa.
I'm still fine.
Thank you very much. Neo Mudiane.
No questions, sir.
Thank you very much. Lesedi Katadi.
I'm good, sir.
Thank you very much. Ladies and gentlemen, let's do this exercise together. Exercise number 1. Just for the sake of it. I don't know how to write the information. Maybe let me just draw a sketch. And then I am told A, B, C. And the examiner says the total time taken by the projectile, by the object to complete the motion A, B, C is 4 seconds. That is all that this guy is telling me. Now, first question is calculate the initial velocity of the object. Let's say, where do we start?
Us writing the variables that we have.
Variables that we have, what we actually understand about the diagram. Very, very important. First thing is to say I am told T total. Let's write it the right way. T total is equals to 4 seconds. What does it mean about TBC and TAB? Now we are told that T total is now 4 seconds. What is the value of TAB?
So it's 2 seconds.
2 seconds. BC? Obviously another 2 seconds.
2 seconds, sir.
Thank you. Another 2 seconds. But if you do not understand the concept of symmetry, automatically that will fall off and then it's going to be a blind spot on you. Now, the examiner says calculate the velocity of the object. Can you see the initial velocity? So you cannot be trying to work with ABC. You can maybe work with AP. So I am going to tell the examiner to say for motion of AB, because let's say this said we must write down the variables. I want to write the variable, but I am only focusing on AB. Why? Because my V initial is there, ladies and gentlemen. What do I have? T is equals to 2 seconds. G is a constant 9.8 meters per second squared. V initial, it is the question. Now, how many variables do we need? 3. I already have 2. Where is the other one, Moteo?
It's the final velocity, which is 0.
Final velocity, which is 0 meters per second. Why, ladies and gentlemen, this is now at maximum height. Very, very, very important. Hence we said here, let me quickly take you back. Hence we said the two variables will be easy for you to identify, but this one that is there but hidden, believe you me, is the one that you now must apply the physics principles. And if you can do that, believe you me, we are home and dry. Ladies and gentlemen, with that, it means when I check the equations that I can use, I can just say VF is equals to VI plus GT. This is 0. Choice of direction. The same mistake that majority of us will do. So I am going to choose upward as positive, which means V initial plus minus 9.8 multiplied by 2. And it means my V initial, okay, let me write the right way, minus 19.6, and then V initial is equals to 19.6 meters per second, comma, this is now upwards. Why is it upwards? The answer is positive, and I chose my upward, ladies and gentlemen, as now what? Positive. At B, the examiner now says calculate height AB. Calculate height AB. Where do we start, Mr. Ditave?
Do we write down the variables?
Variables. T is given 2 seconds. V final is equals to 0 meters per second. Can I trust my answer at 19.6? If I have done everything right, yes, I can trust it. Then I can easily say V initial 19.8 meters, or 19.6. 19.6 meters per second. Then do we have G? Yes, G is given, it's 9.8 meters per second. Then everything becomes easy. V final squared is equals to V initial squared plus GT, not correct, 2G delta Y. Then 0 squared, 19.6 squared, squared plus 2 multiplied by minus 9.8 delta y, and the final answer of delta y, it's 19.6 meters. At C, total distance covered. Bonolo, oh, she's not here. Let's check. Moteo, total distance covered. What is the total?
Wait.
Total
Yeah,
distance 19.6
meters.
plus 19.6. Why? Remember, according to symmetry, AB is equals to BC. So we don't want the displacement covered, we actually want the distance. What is the distance? It is the total motion covered by the ball or the object in this instance. And this, ladies and gentlemen, it will give you something like 39,2 meters. Now let's write down total displacement Bonolo. Total displacement is equals to
Isn't it 0, sir?
0 meters per second. Very easy, ladies and gentlemen. Very, 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 very easy. Very, very easy. But now there's a question here that says, now draw velocity versus time graph. Velocity versus time graph. Ladies and gentlemen, you automatically need to have your axis. Then you write to say this is a velocity and this is now your time. Simple as that. We said upward is positive, so everything this side it means upwards. Everything this side it means downwards. Our graphs here, the plus and the minus, they don't indicate as in the mathematics to say which one is bigger, which one is small. The plus and the minus, ladies and gentlemen, they only indicate the direction of the projectile. Because somebody will say, but that number positive means more, negative means what. Now, where did it start? It started at the top, positive, and then where did it go? It went to the maximum height. Now I'm going to make my life easy and put labels. This is A, this is B. Why is it at B 0, ladies and gentlemen? Because it is touching the x-axis of time, and we said everything on the axis is 0. But it further went on and moved something like that. Then it reached point C. And when I check there, ladies and gentlemen, this must also be 19.6 and there also must be 19.6. But here we know V is equals to 0 meters per second. This is the easiest way of now what? Understanding exactly what happened to the projectile itself. We are not complicating the science, but we are just trying to ensure that each and every one of us understands how we got to the graph itself. So this interpretation, ladies and gentlemen, if I am given a graph, I must also be able to take it back to the sketch. If I am given the sketch or the statement, I must be able to take the statement and convert it into either a graph as well as the sketch, because for me to come to velocity versus time, it became easy only because of understanding the principle, understanding exactly what is happening. I can also include my time to say that is 2 seconds, and maybe there it will now also be 4 seconds. Ladies and gentlemen, now let's draw, it's number F, position versus time. If I want to draw position versus time, very easy. position versus time. I'm going to try and draw the arc and see if it is assisting, not assisting. Maybe yes. Then maybe we can have another one. And just join the two. Something like that. Something like that. And we can easily say here is the maximum height. I can also write again A, B, C. Hence we say the displacement is 0. And then you can say here it is 2 seconds and there it is 4 seconds. And this is just time in seconds, and this is just now position, ladies and gentlemen, in what? In meters. And that is how simple it looks. Mr. Ditawe, questions please.
No questions, I'm good.
Thank you very much. Motewo.
I'm fine, sir.
Thank you very much. VC.
I'm okay, sir.
Thank you very much. Now Mudiana.
No questions, sir.
Thank you very much. And Lesedi.
No question, sir.
Thank you very much, Lesedi. And Bonolo Matosa.
Sir, no questions from my side.
Thank you very much. Thank you very much. Ladies and gentlemen, let's move. Type number 3. Thrown up. And passes the starting point and hits the ground. Let's write it down. Thrown up. It is thrown up. Passes the starting point. Passes the starting point and hits the ground. A, B, C, D. Maybe you are going to ask me, that number, do I have to write down ABC? What do you think, Bonolo? Do we need to write ABC? Do we need to draw the sketch?
Yes, sir.
So in an exam, are you going to draw the sketch on the answer sheet or on your script? Rough notes?
On the answer sheet, sir.
On the answer sheet, 100%. Why on the answer sheet, ladies and gentlemen? When you say for motion AB, the examiner or the marker. Remember, you are going to be marked by the teacher from Fontaine there. The marker must be able to check and relate to where AB is. So this, believe you me, is going to assist you to actually answer very, very complex questions. Very, very, very complex questions. Because already it looks like something that you know. ABC, you already know what's happening there. The only extension is just CD. Even if I am going to introduce another object or something, but for this object, ABC, very confident. CD, can I just read CD as AB or BC? Of course I can, depending on what information is given. So already this complicated statement of thrown up and passes the starting point and hits the ground, I have already eliminated a lot of things. Why? Because if I were to look into this, ladies and gentlemen, up to there, let's change the color and make it red and maybe increase size. Up to there, ladies and gentlemen, I know everything about ABC. Same thing. V initial decreases from A to B at maximum height 0. Let's write all those things. V initial greater than 0. V 0 meters per second. But what about at V at C greater than 0 meters per second? Must write that as a unit. Very, very important. What does it happen now? It means at the ground I must have another V final, which is greater than 0 meters per second. Greater than 0 meters per second, ladies and gentlemen. Moteo, does it become easy for me to say if the examiner asks me something here between C and D, is it easy for me to say I can relate that information and tell him to say I am looking at the motion of CD? Is it going to be easy?
Yes, sir.
100%, because you're only focusing on CD. But imagine if this diagram was just something like this and they ask you something there. Let me use red, something there. VC, honestly, and Mr. Ditavi, what will you say? How are you going to have a reference of answering questions on this particular point? How are you going to answer that? Mr. Ditabe, if you don't have the, how are you going to answer that? Just out of the blue, just tell me for the sake of happiness.
So I don't think it will be easy to answer it.
Because you also don't know where will you be in the motion of the projectile. Hence, 100%. Hence, ladies and gentlemen, science, like I always said for those who have been here for years now, science is a dynamic subject. There's nothing wrong to break it down into sections. And when you break it down into sections, it becomes easy for us to actually know where we are in the motion of the projectile. So I'm just going to say, okay, I am working with CD, then write the variables of CD. Automatically I'm closer to the right answer. Why am I closer to the right answer, ladies and gentlemen? Because I am within the points of which the examiner will want. Maybe let me ask, now Mudiana, do you have a question paper and a memo of the previous years?
No, sir, I don't.
Okay, let's say the previous question papers with answers, maybe memorandum.
No, sir.
Okay, no problem. Mr. Ditabe, do you have?
Yes, sir.
Thank you. If you have, ladies and gentlemen, you will see for paper 1 it's option 1 up to option number 9. Why so many options? The interpretation of the science. One learner will say I'm working with A, B, C, D. One will say I'm working with B, C, D. One will say I'm working with C, D. You understand? But if you don't have the sketch to understand where you are going to get lost. And ladies and gentlemen, the question papers are available on the Nambane Academy. I will show you now. Before you leave, you must all get, for the purpose of practice as well as just to see how these people ask these nice questions. Ladies and gentlemen, this is type number 3. Let's move with type number 3. I don't even know what to say. For AB, V initial greater than 0, that means decreases from, okay, let's say decreases as it approaches maximum. Height. Let's go at C. What do we know at C? V final is equals to V initial. It's type 2, ladies and gentlemen. Delta Y is equals to 0. And T1 is equals to T2. Where is T1? T1 is there. T2 is there. Easy. And then what about at D, ladies and gentlemen? At D, which is at the ground now. V final greater than 0 or comma increases as the projectile approaches the ground. Full stop. Full stop. Questions, Moteo?
I'm good, sir.
Thank you very much. I'm trying to think of an example. Okay, the example will be, let me copy this. It means this topic is long. Let me this, clean it up. And no, undo. Yes, and just duplicate the clean one. 1, 2, 3, 4, 5. Thank you. Thank you. Yes. Let's do this one quickly. It is now exercise number 2. Exercise number 2. A learner throws a ball vertically upward with a velocity of 20 meters per second from a height, from a top of the building, with the height of 25, 51 meters. Yes. Mr. Ditabe, where do we start?
Variables.
Incorrect. Moteo.
Oh, sketch. Trajectory.
Thank you very much. We start with the trajectory. Why the trajectory, ladies and gentlemen? The trajectory will assist us to know what is happening here. Top of the building. Simple. There. Top of the building. Ball thrown vertically up. It is starting there. Vertically up. Comes down. Okay. And hits the ground. That is important to know that it actually passed the starting point. Then it went down, and we say this is the ground, and then it went down. Then what must we do? Add A, B, C, D. Given information, vertically upward with a velocity of 20 at A, 20 meters per second. At the maximum height, V is equals to 0 meters per second. At C, 20 meters per second. Where do I know this from? Type 2, ladies and gentlemen. Issues of symmetry. Very important. Very important. Do I know the V final here? No, I do not know. But I am told that this here it is 25,51 meters. Listen, then I can basically just answer any question. Let's start with the first one. What is the first one? The first one is to say calculate the time taken to reach the maximum height. A, calculate time taken to reach maximum height. Moteo, variables. G, always given 90.8 meters per second. What else is given? V initial 20 meters per second. What else is given? V final. Why do we say it's given? We know the principle to say at the maximum height V final is equals to 0, but it is not equals to 0. Let's do this. I want to take this thing somewhere down. Come on. Okay, we will add it 0 meters per second. What is the question, it is the time. V final, okay, V final is equals to Vi plus GT. We agreed upward as positive, so the projectile is still going up. Everything must be positive, but G, because it is downwards, it must be negative. Then how do we do that? Very easy. We just say this will be 0, 20 must be positive upward, minus 9.8 t, and then when you work with the calculator you have 9.8 t, 20 divided by 9.8 divided by 9.8, they cancel, they give you t, which is something like 2,04 seconds. But now that is the time taken to complete the motion of, let me write, A to B. Now Moteo, my question should be, what is the time taken to complete motion A, B, C? Moteo?
We times our answer from A by 2 to get our time for ABC.
TABC will be now 2 multiplied by 2,04. But okay, that is correct. It will give us an answer of something like 4,08 seconds. However, I prefer to say T of ABC is actually T of AB plus T of BC, to indicate that I understand the issues of symmetry, which will be 2,04 plus 2,04, which will give us 4,08 seconds. It's basically the same thing, but just playing around with weights. So for me, I prefer this one. Why this one, ladies and gentlemen? It will sit consciously in my mind to say T1, T2. It actually means T1 and T2 are equal. Why? Issues of symmetry as per type number 2. Ladies and gentlemen, let's move now. And if we move, ladies and gentlemen, we want to say at number C, calculate the height. Calculate the height above the ground. Where do we start, Bonolo? Calculate the height of the ball above the ground.
Sir, aren't you gonna like work from C to D?
C to D, we have C to D is 25,51 meters. Remember, that is now the height of the that we have. The question is not above the height of the building, but above the ground. So above the ground means from there to there. So how can we go about this one, Mr. Ditade?
So, can't we use the equations of motion?
Obvious, we are going to use that. My question is, how do we approach this one? Yeah, Moteo.
We're gonna use the the equations on BC and then add it with CD to get our total height.
Thank you very much. Now, ladies and gentlemen, Mr. Ditadi, Bonor, let's look at this thing. The sketch basically says that this will be BC and this will be DC. We already have CD, which is 25,51 meters. So it basically says I just need to get the delta Y of now what? BC. Can you see it, Mr. Ditabe?
Yes, sir.
Then if I have that height of BC, I can just add BC and CD together. Then I have the total to say the height above the ground. BC or AB is just the height above the building. So when we want the height above the ground, it must be everything until there. Lesedi, can you see the importance of having the sketch?